Today we're unpacking the incredibly dramatic life and the truly revolutionary economic theories of Nicholas Georgescu Roegen. Now, if you've ever wondered where the modern degrowth movement actually comes from, or why so many scientists are suddenly arguing that infinite economic growth on a finite planet is just physically impossible, well, you are in exactly the right place. We're going to dive deep into the mind of a guy whose literal fight for survival completely reshaped how we understand the environment and the economy. And right out of the gate, let's hit on a wonderfully sharp and honestly pretty provocative criticism of mainstream environmentalism from the man himself. He stated, quite bluntly, "There are no doubts sustainable development is one of the most toxic recipes." Just let that sink in for a second. That's a massive paradigm shift. Why on earth would a founding father of ecological economics call the very concept of sustainable development toxic?
So, who exactly was this forgotten economic heretic? The guy whose warnings we're literally living through today? And maybe the better question is, why did his ideas get totally buried by the mainstream establishment back then, only to reemerge right now as the absolute cornerstone of our modern ecological debate?
To answer those questions, we're going to use this foundational text, From Bioeconomics to Degrowth, edited by Mauro Bonaiuti. This is going to firmly ground our explainer in Georgescu Roegen's actual, original academic work. It's a genuinely brilliant collection that rescues his multidisciplinary genius from obscurity and really lays out the nuts and bolts of his foundational ideas.
Moving into Section 1, Escaping the Dictatorships.
Now, to really grasp his revolutionary theories, we first have to trace a life that was defined by both staggering academic highs and sheer, harrowing physical survival. Because you see, his ideas didn't just pop out of a dusty textbook, they were forged in the trenches of history. Born in Romania in 1906, his crazy math skills took him from an isolated mock military school all the way to universities in Bucharest, Paris, and London. By 1934, he lands in the Ivy League halls of Harvard. But look at this trajectory. He doesn't just stay in that safe academic bubble. He takes a sharp, incredibly dangerous turn back to Romania before a desperate final escape in 1948.
So back in the 1930s, he's an absolute prodigy in pure mathematical economics at Harvard. He's publishing in top-tier journals, and he's even collaborating with Joseph Schumpeter, literally one of the giants of 20th century economics. Basically, a highly successful, completely comfortable career was laid out right in front of him on a silver platter.
Which brings us to a huge question. Why walk away? Why would a brilliant young scholar look at the outstretched hand of the academic establishment, politely decline, and leave all that safety behind?
Well, he was driven by a really profound, unwavering duty to his developing homeland. He truly felt his education had been funded by the Romanian public purse, and he owed them his expertise. So he goes back to act as a diplomat and statistician. But reality hits hard and fast. His life violently collided with history. He somehow survived the intense bombings of World War II, only to then find himself resisting the rise of a ruthless communist dictatorship. He watched authoritarian regimes just rewrite election results overnight and completely disappear their political opponents.
Naturally, his political militancy and sheer refusal to bow to that kind of tyranny eventually forced him and his wife to flee for their lives. The story is wild. In the dead of winter in 1948, they were smuggled out, literally hidden inside a wooden packing case down in the dark, freezing hold of a ship bound for Turkey, before finally making it back to the U.S. Talk about a reality check, right? This experience completely stripped away any academic illusions he had about how the real world actually worked. Which brings us to Section 2, Numbers versus Concepts. So, all those chaotic, terrifying, real-world experiences, they directly fueled his massive intellectual rebellion against standard economics. Unlike his peers who spent their entire lives in peaceful, quiet university offices, his survival through war and dictatorships taught him something absolutely fundamental. Rigid mathematical models completely fail to capture the messy, chaotic reality of human life. He fiercely criticized what he called physics envy. This weird obsession mainstream economists have with trying to force complex human behavior into mechanistic, perfectly predictable mathematical equations. To really explain why this physics envy is such a trap, he split human understanding into two totally distinct categories: arithmomorphic concepts on one side and dialectical concepts on the other. Grasping this distinction is literally the master key to unlocking his entire philosophy. Let's start with arithmomorphic concepts. It's a mouthful, I know, but it just means discretely distinct concepts with absolutely zero overlapping. Think of the zeros and ones in a computer program, or the exact geometric definition of a triangle. These concepts are perfect for pure math and strict logic because they are absolute. There are no gray areas whatsoever. A number is exactly what it is.
Now, contrast that with dialectical concepts. These have what he called shifting penumbras, meaning they have hazy, fluid borders that actually overlap their opposites. Think about it. Try strictly defining the exact minute someone goes from being young to old, or the precise moment a democracy slips into being an oligarchy. You can't, right? Because dialectical concepts are how actual life works. They overlap, they evolve, and they are absolutely essential for understanding human values, institutions, and biological change. His core thesis boils down to this fantastic quote: "Wherever there is life, movement, and change, there dialectics is at work." He realized that an economy isn't a simple mechanical clock. It's a living, breathing, constantly changing biological and social system. The fatal error of standard economics is trying to map a living, dialectical world using only dead, rigid, arithmomorphic numbers.
Let's look at what happens when you ignore this in Section 3, the problem of scale. So how does this philosophical stance completely dismantle our modern obsession with endless economic growth? It all comes down to a concept he termed the qualitative residual. Standard economists tend to think you can infinitely scale up production by just mathematically adding more inputs. To them, it's simple math. They treat complex natural resources exactly the same way you would weigh a homogeneous pile of flour. But doing that completely ignores the qualitative residual. When you scale up physical transformations in the real world, things change qualitatively, like the actual hardness of a material or its heat resistance. These non-linear biological and physical transformations will eventually break the mathematical models when you push them to extreme scales.
The stark contrast we're looking at is this. Standard economics is functionally indifferent to scale. It operates on this fantasy that growth can just continue forever and ever. Bioeconomics, conversely, is highly sensitive to scale. It acknowledges the hard truth that endless growth on a finite planet triggers devastating ecological and social consequences. Why? Because physical matter literally cannot be infinitely manipulated without degrading.
Which leads us to our final part, Section 4, the birth of bioeconomics and degrowth.
Georgescu-Roegen synthesized his entire life's work into bioeconomics. This was the brilliant multidisciplinary marriage of economics, thermodynamics, and evolutionary biology. By applying the laws of thermodynamics, specifically the law of entropy, which dictates that energy and matter irreversibly dissipate over time, he argued that there are absolute, unavoidable biophysical limits to economic growth. By doing this, he laid the hard scientific foundation for the modern sustainable degrowth movement. And this is exactly why he called sustainable development toxic earlier on. Because according to him, you simply cannot sustain infinite development in a system that is bound by the strict, unyielding laws of entropy.
So how do all of these threads build into his ultimate paradigm for the path forward? First, we, humanity, must acknowledge our long-term biophysical limits, things like climate change and resource exhaustion. We have to recognize that our massive current multinational institutions only know how to function in a growth economy. If the economy shrinks, they fail. Therefore, he argues we must prepare for a radical transition to zero growth. We have to cultivate what's called a new social imaginary, basically a completely new cultural framework, so we can intentionally choose our future path before nature violently chooses it for us.
I want to leave you with this final thought. As we hit the absolute limits of our biosphere, humanity has to actively negotiate a new way of living. Within just a few decades, how will our basic economic institutions transform to survive the end of endless growth? And maybe more importantly, what will you do to help shape that necessary society of tomorrow? Thanks for diving into this explainer with me, and as always, keep questioning the systems around you.